Assalamualaikum to the panelists. Today, I want to present about my topic, which is a fabricated of an automated collision avoidance system using ultrasonic sensor. My supervisor is SAHRIL KUSHAIRI. Here is a project summary. As we know, vehicles accidents are very common in Malaysia. This is because of the increasing population, which lead to more vehicles on the road. This type of accident can have a serious threat to life and property. A system that can minimize the probability of the number of vehicle accidents can be designed. So the main objective of this study is to design a device that can scan the surrounding during driving and apply brake to avoid collision at the front end of a vehicle. An ultrasonic sensor on the front end of the vehicle will detect the presence of the obstacle. Then the Arduino microcontroller is used to process the signal and to prevent collision using the braking system or auto speed reduction system. The driver alert mechanism is included to alert the driver at a safe braking distance from collisions. The driver alert mechanism that is used in this project is a buzzer. By using this as the alert mechanism, it can signal the driver to manually reduce the speed by applying brake system or without the help of auto speed reduction system. As for the introduction, vehicle safety is an important concern from the vehicle design stage. Several technologies such as seat belts and airbags have proven successful and useful in accidental situations. The automatic collision avoidance system is a system for avoiding the seriousness of an accident. This is an electrically controlled aimed at avoiding frontal collision of vehicle and improving collision safety. This is achieved by an automatic speed reduction system. The system uses high-frequency ultrasonic to detect obstacles and calculate the distance between the obstacle and the vehicle. Collision predictions are tracked and the driver is warned that a collision is imminent. The driver will be warned twice at 80 cm and 50 cm. If the delay continues, the microcontroller simultaneously notifies the operation of the automatic speed reduction system. The combination of these circuits effectively avoid collision and reduce damage to the vehicle. Here is my first literature review by Wenji Song. It presents a real-time and robust lane detection and forward collision warning technique based on stereo camera. Obstacle image is obtained through stereo matching and UV disparity segmentation algorithm. Then, inverse perspective mapping and solar filtering are conducted to generate a low noise top view of the road by fusing the obstacle image and the original image. Next, huge transformation for the top view image is completed and the action points are calculated as the detected lanes according to the traffic lanes model. The host lane is selected or supplemented among all the detected lanes and the nearest obstacle in this host lane is detected for the forward collision warning. Experimental results on the public data set indicate that the auto method can work effectively and in real time in the normal structural environment. However, the system is sometimes influenced by the back factor like railway track, traffic light, railway track light reflecting or dancing light on the road, which can lead to false detection of lane samples. Author Narayan Srinivasa proposed a vision-based vehicle detection and tracking method for forward collision warning in automobiles. The approach used is based on a set of edge-based constraint filters that assist in the segmentation of vehicles from background clutter. The system works well since the algorithm does not rely on lane tracking for processing, and it can complement any forward collision warning system for threat assessment. Since the system uses camera in its edge detection, bad weather can induce noise which leads to significant number of false negatives. This is the literature review number 3 by Shahrul and Jayavel. In this paper, They deal with advanced thought which include pre-crash sensing, ultrasonic sensing, and ultrasonic sensing is used to experience the item in front of the vehicle and give the signal to the microcontroller unit based totally on the signals received from the ultrasonic sensor. The microcontroller unit is sending a signal to the braking unit for applying the brake automatically. The problem statement: all common vehicles are equipped with manual braking. The outcome of a collision depends on the driver reflexes to change the driving environment. Traffic accidents can be caused by driving in a hurry, drunk driving, or fatigue. Most of this can be traced back to the single cause, which is the driver not being able to apply the brake at the right time. Replacing this task with an automated means can control most collisions. Next is the objective for this FYP. Nowadays, all common cars only have sensor while they are driving in reverse, and it is proven that putting sensor on a vehicle can reduce the probability of a collision. Therefore, in this project, we want to put the sensor at the front end. The sensor can warn the driver in 3 phases during driving, so the effectiveness of the sensor can be maximized for the benefit of the driver. The objective for this project is that I want to create a system in a vehicle that can help alert the driver to avoid front-end collision. And I want to create a system that automatically stops the vehicle that can avoid collisions. The purpose of the project is to fabricate an automated collision avoid system using ultrasonic sensor. There will be 2 functions in the system. The first one is that the system can reduce the speed of vehicle and fully stop it. And the next is that the system has a warning mechanism that is useful for the driver. The test will have a several number of samples, since it has 2 functions in the system, the minimum of sample is 3, one for each function, and the another one is for the whole project, where both of the system will be combined. The study will be conducted in a workshop. Since it involves fabrication, it is safe to say that the project will be conducted in a workshop. There will be several number of variables while doing the project. One of them is that what is the maximum speed that the sensor can detect. The limitation is that the resource and the lack is the resource for this project and the lack of information about the system. Since for this proposal I have do an online research, the information about the system is very limited. As for the resources, the to set up the whole project after doing the research is very expensive for a student. As for the methodology, the method that is used while doing the proposal for this project is an online research and simulation. The simulation software that is used for this project is Tinkercad. Tinkercad is suitable for this project since it uses ultrasonic sensor that is related to the Arduino. The data is collected by doing online research about the safety distance between a car. As expected result, based on the research that has been made, the data that has been collected is very convincing. There are 3 zones for the sensor to work: the safe zone, the caution zone, and the danger zone. The LED will turn on at the caution zone and the danger zone, and at the danger zone, the buzzer will turn on. After the danger zone, the vehicle will completely stop. This is the example for the Tinkercad, and the right is the what I talk about the zone, how the system will work with the zone. This is the coding for the whole system. That's all from me. Thank you.